So back in the compound events number 1 video, I drew this tree diagram for Sunil and Monica's archery contest. And I want to talk a little bit more about this. What we can do that will actually make calculating probability easier is we can write probabilities on these branches and then figure out the probability of all this stuff using that. So probability of a hit is 4/5, so I'm going to label that branch 4/5. Of a miss would then be 1/5. Probability that Monica hits is 5/6, and that Monica misses is 1/6. So 5/6, 1/6. And what we can do is we can now follow these branches out to calculate the probabilities of everything in the sample space. Probability that Sunil hits and Monica hits is going to be 4/5 times 5/6. Probability that Sunil hits and Monica misses, so following this second branch on the top, 4/5 times 1/6. And we can calculate what these are all equal to. And I'm going to do that, I suppose. So this one was 2/3. This one would be 4/5 times 1/6. 2 goes into 4 twice. 2 goes into 6 3 times. 2 out of 15. Probability that Sunil misses and Monica hits would be the third probability I can find. So this is 1/5 times 5/6. And finally, probability that Sunil misses and Monica misses, 1/5 times 1/6. And this was equal to 1/30. And now here's the cool thing. If I take all these probabilities that I just found and add them, the sum equals 1. If we've done this right, if we've listed our sample space correctly with the tree diagram and labeled the branches correctly, it should be showing every possible thing that could happen. So if we add up all the probabilities, they better equal 1. So let's see if we can't do another example. Stefano, he's having problems. His desktop computer will only boot up 90% of the time, and his laptop will only boot up 70% of the time. So he's probably not using a Mac. He's probably using a PC. Little Mac humor. So we're going to draw a tree diagram to illustrate this situation. What I'm going to say is C is going to be computer works. And L, laptop works. And by works, I mean it boots up. So let's draw a tree diagram to show this situation. So C, start with that. C. What's the probability of C? Well, it's 90%, so I'm going to put 0.9 on that branch. From the Venn diagram section, you might remember this notation, not C, the complement of C, C prime. So C is the computer works, C prime, not C, would be the computer doesn't work, and that's 0.1. Off of each of these, we're now looking at the laptop, L or L prime, L or not L. And the probability of L is 70%. Probability of not L then has to be 30%, 0.3. And remember, using percentages in mathematics, we always have to change to decimals. And now part B says use the tree diagram to determine the chance that both will boot up. Let's find the branch where that happens. So we want C, we want L. That branch is the one that will find us probability of C and L. So 0.9 times 0.7, 0.63. Stefano has no choice but to use his desktop computer. Okay, so we have to do a little interpreting here. Probability that the desktop works, but the laptop doesn't. So probability that the computer works and the laptop doesn't. That's the only way that he's going to be able to use the desktop is if the laptop doesn't work. So this would be 0.9 times 0.3, 0.27. 0.27% of the time, he's going to be stuck with his laptop only and not his desktop. So now we have a real tasty problem. We've got jelly beans. Bag A has 4 red and 1 yellow. Kind of a cheap situation, only 5 jelly beans in the bag, but hey, it is what it is. And bag B, we have 2 red and 3 yellow. A bag is randomly selected by tossing a coin, and 1 jelly bean is removed. Determine the probability it's yellow. So let's start by thinking about what are the 2 events that are happening here, because there are 2. The first event that happens is we choose the bag. We choose bag A, we choose bag B. And once we choose that, we're going to be picking out of there. We could get red, we could get yellow. And now let's label the probability. What's the probability that we select bag A? Well, how are we choosing it? I forget. Oh, we're tossing a coin. So the probability that we get A is 1/2. And in bag A, what's the probability of getting a red? A red would be 4/5. A yellow would be 1/5. In bag B, again, probability of 1/2 of getting bag B. Bag B has 2 red out of 5 total and 3 yellow. So 3 out of 5. Okay, now here's the big question. In what ways can we get a yellow jelly bean? Well, there's actually 2. There's 2 branches that we are concerned with here. We want the probability of getting a yellow. Doesn't matter what bag it's in. So what we have to do here is we have to take 1/2 times 1/5 plus the other branch, 1/2 times 3/5. 1/10 plus 3/10, 4/10, which is 2/5 of the time we'll get one of those tasty yellow jelly beans.